We finished learning workbook page 135 with this problem. If Claude throws a ball upward with an initial speed of 32 feet per second, then its height h after t seconds is given by the equation h of t equals negative 16t squared plus 32t. Now, before I read the parts that we're being asked to find for this problem, I'd like to share with you that this is a real equation that comes from physics. When you take a physics class, you learn that gravity is 32.2 feet per second squared. And when you learn to derive equations that describe how objects move through time and space, the value of gravity gets divided by 2 while you're deriving those equations. 32.2 divided by 2 is 16.1, which is where the 16 comes from. They rounded down to 16. The reason why it's negative 16 is because gravity pulls things down. All right, the 32 comes from this value, the initial speed. Both of those things give us this real-world physics equation that describes how a ball moves through time and space. Here are the 3 questions we're being asked to answer. A, this function has a maximum value. What part of the equation proves this? B, find the maximum height of the ball. C, how long does it take the ball to reach its maximum height? Okay, let's start with part A. This function has a maximum value. What part of the equation proves this? Well, this equation is in the standard form. Instead of the variables h and t, we could use the variables x and y. We would see that this is f of x equals negative 16x squared plus 32x, which means a is negative 16. The negative part is the most important part of that. If something is negative, that means that it opens down. And if something opens down, that means that the vertex is a maximum. So the part of the equation that proves that this function has a maximum value is the coefficient a, which is negative 16. The fact that it's negative is what we're paying attention to here. Part B, find the maximum height of the ball. Part C, how long does it take the ball to reach its maximum height? Both of those questions are answered by finding the vertex. When you see a problem that uses an extreme word like minimum or maximum, verify that your equation is quadratic, because if it is, the vertex will answer the question. Well, this is definitely quadratic. ax squared plus bx plus c. A is negative 16, b is 32, c is 0. So let's write those things down. A equals negative 16, b equals 32, c equals 0. The formula for the vertex is opposite b over 2a, comma, c minus b squared over 4a. Let's plug in. Opposite b, so that's opposite 32, so that's negative 32, divided by 2 times negative 16. There's our x-coordinate. C is 0. C will not always be 0. Just keep that in mind. It's a coincidence that the last couple of problems, C has been 0 every time. C will not always be 0. 0 subtract b squared, so that's 32 squared, over 4 times negative 16. All right, so this down here, 2 times negative 16 is negative 32, and negative 32 divided by another negative 32 is 1. Let's follow the advice that I gave you in the previous video. You should do the fraction before the subtraction. 32 squared is 1024. 4 times negative 16 is negative 64. And we're going to do the fraction here before we pay any attention to this subtraction sign. All right, 1024 divided by negative 64 is equal to negative 16. So we have 1, 0 minus negative 16. Subtracting a negative is adding, and 0 plus 16 is 16. So I get 1, 16. Now we have to interpret this vertex. How does this help us answer the problem? Well, this is clearly an ordered pair. It's an x and a y. And if you look at the comparison that we made between the equation we were given in the standard form, you can see that the t is sitting in the x position. And f of x, which we usually associate with y, is actually giving us the height. So x is t, y is h of t. So we're getting the time from the x value, and we're getting the height from the y value. This allows us to answer both questions. Find the maximum height of the ball. So that's going to be the y value. So the answer to part B is 16, and the units of measurement are feet. Part C, how long does it take to reach the maximum height? Well, that's referring to the time, which is the x value, which is 1 second. So this ball's moving pretty fast. It takes just 1 second for it to reach its maximum height of 16 feet.